Hello and welcome to Chemistrymasters. So in today's video we are going to discuss about the pi molecular orbital formation for ethene. So here you will be understanding that how does the molecular orbital of ethene is formed and what is the concept behind the atomic orbital, molecular orbital and nodes. So let us begin. Condition of understanding the molecular orbital formation of ethene molecule, we should be knowing about some basic concept. So here are some of the basic concepts which are related to all the type of pi system which we will be discussing out here. So the first very much important point is that the number of molecular orbital which are being formed, their number will be always equal to the number of atomic orbital. And it is always should be remembered to us that atomic orbital get joined or the atomic orbital makes the molecular orbital. So if you remember in your lower classes, you might have seen this particular structure where we discuss about the formation of molecular orbitals from atomic orbital. So if you remember the formation of hydrogen molecule, that is H2 molecule. So in H2 molecule, we all know that hydrogen molecule is made up of two hydrogen atoms. These hydrogen atoms get combined to make molecule, that is H2 molecule. So we all know that again the electron are present in the atomic orbitals, which are present in the atomic orbital, they combine to form these two molecular orbitals. Okay, and yes, their energy is different, and as the energy is different, the electrons always start to fill up from the lower energy level, and when they are filled, then they can go to the higher energy level. So that same concept you might have discussed in the inorganic chemistry in your lower classes. So same concept is taken here also in the pi system which are undergoing the pericyclic reactions. Now the another concept which is very much important out here is that whenever the molecular orbitals are formed, generally half of them are of bonding type and half of them are of anti-bonding type. So bonding type molecular orbital will be having lower energy as compared to the atomic orbitals. If you see the atomic orbital which is present here and this one also, these are having much higher energy as compared to this bonding orbital. So this is the bonding orbital and this is your anti-bonding orbital, or which is also known as ABMO or BMO also. Okay. So you can write it BO or you can write it BMO or ABMO. So this point we already have discussed that molecular orbitals are formed and they do have different energy. The bonding orbital will be having lower energy as compared to the anti-bonding orbital. Okay, so this is the third point. The ABMO, that is anti-bonding molecular orbital, is always of higher energy as compared to bonding molecular orbitals. Now we will be taking the same concept of formation of molecular orbital in terms of ethene molecule. Now if you talk about the ethene molecule, this is the structure of ethene molecule where CH2 double bond CH2 is written. And if you see in ethene molecule, there is a presence of a double bond, and we already have discussed in our last lecture that double bond is required in the case of pericyclic reactions. Now this double bond is associated with these two carbon. So these two carbon, or you can see its orbitals, will be going in the pericyclic reaction, or the electron which are present in these orbital of these two carbon, they will be responsible for the pericyclic reaction. So this particular ethene molecule can be shown in terms of orbital in this form. Now orbitals are always shown in form of lobes. So these are the lobes which we have shown here. So they can be shown in form of filled and unfilled lobes, or they can be sometimes shown in form of positive and negative, like this. Now each of the orbital which we are taking, it do have two lobes. One of them is above, you can see this red one, another one is this white one, or as we already have said that as a plus or minus it could be. Now whenever these orbitals are present there, these are responsible for the particular reaction. Now here we will discuss that how these molecular orbital in ethenes are obtained by these two atomic orbital of respective carbons. So for that you can consider this particular structure. So for first carbon, you can say for the first carbon this particular lobe is there, and for the another carbon, second carbon, the other lobe is there. So these are two atomic orbitals of two carbons, these two carbons. Now we already know that these will be joining to each other, and when they will join to each other, when they will come near to each other, they will be forming the molecular orbitals. Now these molecular orbitals, their number will be always equals to the number of atomic orbitals. So if you see there are two atomic orbitals, that means there will be formation of two molecular orbitals. Now two molecular orbitals, certainly we already have discussed that the two molecular orbitals which will be forming, one of them will be bonding molecular orbital, so we can write it as BMO, and BMO is always having the lower energy, and the another molecular orbital which will be formed will be called as ABMO, that is anti-bonding molecular orbital, which will be having higher energy, as you can see here. Now these two orbitals will be formed, and very much important thing which you can see here is that the two molecular orbitals which has been formed out here, they are having different arrangement of the lobes which are present there. Now out of these two molecular orbitals which we have got, first we will discuss about the bonding molecular orbital. So if you see the bonding molecular orbital, in that the same type of lobes, they interact with each other. So if you see, you can say it as a plus, or you can call it as a filled one. So here the interaction between the same type of orbital is there. So you can say the addition of wave function is there. So same type of lobes are on the same side. That is known as constructive overlap. So constructive overlap is same type of lobe on the same side. If you talk about the anti-bonding molecular orbital, in anti-bonding molecular orbital we can see that two opposite type of orbitals are present. These are of two opposite type. So this is known as destructive overlap, or you can say there is cancellation of wave function of these two orbitals, and that's why due to destructive structure, or you can say due to the two opposite type of lobes are present on the same side, the energy of this anti-bonding molecular orbital is always high as compared to bonding molecular orbital. So the next very important component regarding the pi molecular orbital formation is about the nodes. So nodes tells that how does these orbitals are arranged in a particular molecule. Now if you talk about the example of ethene, in case of ethene we have seen that in the molecular orbital the arrangement of the lobes could be on the same side, that is known as constructive overlap, as you can see in this particular picture, or it could be destructive also. That means the two orbitals, in that the lobes will be arranged in opposite form. So whenever the lobes are present on the same side, as you can say, the filled one or the red one are on the same side, the unfilled one are on the other side, in that case we will say that there is no node formation, there is zero node formation. While if you talk about the another one where there is destructive overlapping, where the two lobes are on the opposite sides like this, in that case there is formation of a node, which is generally shown with the help of a dot like this in between the two orbitals. Now, the one component which should be always remembered to us, that the number of nodes will be always equals to the energy level minus 1. If you see the earlier picture, here if you see that in this one, which is of lower energy, so you can call it as the psi 1 and this one as psi 2. So this is your first energy level, the lower one, psi 1 is your first energy level, psi 2 is your second energy level. So if you want to tell about that how many nodes will be in this first energy molecular orbital or bonding molecular orbital, then the nodes will be equals to energy level, that is your first energy level, minus 1, that is equals to 0. That means there will be no node in this particular bonding molecular orbital. If you talk about the anti-bonding molecular orbital and how many number of nodes will be there, so that will depend upon the same formula. So number of nodes will be equals to the energy level. So this is your second energy level, which is written as psi 2 here, or in many of the case it is written also as the psi 2 star. Stars generally tells you that this is your anti-bonding molecular orbital. So it will be 2 minus 1, that is 1. That means there will be one node. One node tells you that these two lobes will be in opposite direction to each other. So this was all about today's lecture. So where we have discussed about the formation of pi molecular orbital of ethene molecule. In the next lecture we will be discussing about the formation of pi molecular orbital of 1,3-butadiene structure. Please share our video with our friends, like it, share it, and don't forget to subscribe our channel. Thank you for watching.